This example is going to show you how to create a frequency distribution if you don't happen to like the histogram that R creates automatically. In most cases, I wouldn't suggest doing this, but there are a couple occasions where you may want to pick your own frequency distribution and then create a histogram from that. So as always, go ahead and type the data in. The data we're going to use, I just copied and pasted this from the notes, is Cancer, is my data set I'm going to call it. And I'm going to read in a CSV file, and this is the web address of that CSV file. Again, it's a good idea to kind of look at what the data looks like. And so if you do a header, it'll show you all the variables in the first few data values that are in this. So this is case 1. It has a survival time of 124, and this person had stomach cancer, and so forth. So you can see what survival time, what the variable survival time is actually typed in as, and what organ is. Make sure you use exactly these when you're going to do the work. Now what we want to do is we want to take basically, instead of letting R create what the x-axis looks like, we want to create our own x-axis. And what I mean by that is we want to say exactly what we want that division to look like on the x-axis. So what we want to do is kind of find out what is the highest and the lowest survival times we have in this data set. So we're going to use the command summary, and we are using the dataset Cancer, and we want to use the variable survival time. And so it's just going to summarize this. This is actually a precursor to things that we're going to be doing when we get into descriptive statistics. And this is just one of the many different commands that we can use for R for when we do descriptive statistics. And what it does is it gives you your minimum. It gives you some things that you may or may not know what these are from previous classes, and then it gives you your maximum. And so what we're basically doing is we're saying we have 20 here on our x-axis, and then we're going all the way up here to 3,808 on the x-axis. And what we want to do is divide this x-axis from 20 all the way up to 3,808 into different groupings or intervals, or what we call classes. And what we want to do is say how many chunks or intervals we want to have, or how many classes we want to have. If I remember this data set, there's only about 63 data values in this data set. So it doesn't make a lot of sense to have like 20 different classes or intervals, because then you're going to have a bunch that have zeros in them. So when you only have around not too many data values, you don't want to have a lot of classes. Anywhere from 5 to 20 is how many classes you're supposed to pick. So if you're going to have very few data values, I would pick something close to 5. Maybe we'll pick 6 this time. And if you've got tens of thousands of data points, that's where you would probably have 20 data values or 20 intervals. So what we want to do is we want to figure out how do we divide 20 to 308 up into these 6 different groupings. So what we have to do is find out how long is this interval from 20 to 3808. So we're going to get something called the class range. And so we take 3088 and subtract off 20. And that tells us that that difference is 3,788, sorry. And you can, as you can see, R does simple arithmetic for you. So I'm sure you could have subtracted the 20 by yourself. So now what we're going to do is we want to chunk this up into chunks of intervals that are with 6 of them. So we're going to take the 3,788, we're going to divide that by 6. What we come up with is that each interval should be 631.33333 repeating in width. So we want to start at 20, add that to get the next grouping, and add that to get the next grouping. Since our data only has whole numbers and not have any decimal places, we really don't want this class width to have decimal places. If your data has several decimal places, then you'd round your class width to the same number of decimal places. Since this is a whole number, we want to round this to a whole number. Now, conventionally, you would say, well, that's 631 is a whole number. But you actually always want to round this up. If you don't round it up, you won't actually get 6 classes. You'd have to actually have another one. So we're going to round this up to 632. I'm not going to actually type that in, but I just wanted to kind of show you that you just round it up to the next whole number. So 632 is what we want to do there, or the next decimal place, whatever one you're dealing with. So now what we're going to do is we're going to break up this number line from 0 here, or from 20 here to 3808. I'm going to break that up into groupings that are 632 in length. So we need to create a new variable. I'm going to call it breaks because we're going to break this up. And this new variable is going to be where we're going to cut. Actually, we're going to sequence the sequence from 20. And I don't want to stop at 3808. I want to go a number bigger than that. So maybe go up to 4,000. That may or may not be big enough, but we'll see. And then we're going to do that by 632. Again, it doesn't look like anything happened, but breaks was actually saved. So if you type in breaks, you can actually see what those groupings are. So the first class or interval starts at 20 and goes up to, but not including, 652. The reason I say not including is that the next class or interval starts at 652, so I don't want it to be included in both. And this one goes from 652 up to, but not including, 1284. The next one goes from 1284, but not including 1916. The next one goes from 1916 up to, but not including 2548. 2548 up to, but not including 3880. The next one goes from 3180 up to, but not including 3812. Now you're saying, well, the maximum is 3808, but this class actually, next one actually starts at 3812 and then goes up to some other number. So we're going to go ahead and go with this and see what happens. So now what we're going to do is we're going to take all of our survival times in this data set and find out how many data values actually fall between 20 and 652, how many fall between 652 and 1284, and so forth. So what we're going to do is we're going to take and kind of chunk up or divide up our survival time data into these classes and count how many are there. So the way we do this is we're going to create a new variable. I'm going to call it, because we're dealing with the cancer data set, I'm going to call it cancer.cut. You can actually call it anything you want. It's just I'm going to cut this data up into these groupings, into these things. And so the variable, the command I use is actually cutting. So I'm going to cut my cancer data set and my survival time variable into based on these breaks. And because I said up to but not including this data value, I don't want to actually include that one. So I'm going to say right equals false. Notice the false is completely capitalized. R is case sensitive. It does consider the word false capitalized different than false lowercase. Make sure you pay attention to your case, cases of your letters when you type them in. Then you just hit enter, and I get some kind of error. I must type, oh, I didn't spell survival correctly, so we're going to go back over. All I did, by the way, is I hit the up arrow, and that brings back up the previous thing you entered. You can keep doing that, by the way, and keep hitting them. Then you can arrow over, and then spell survival correctly. Okay, so now I've created that, and I've cut it up. I don't want to actually look at this, because when I look at this, it gets to be really confusing, and it's not in a nice form. So what I want to do is create a new variable. I'll call it cancer.frequency. And what I'm going to do is I'm going to make it take this cut variable and put it into a nice table. So I want to make a table of this cancer.cut. And then I can look at this and see what it looks like. All right, and so this goes, the first class goes from 20 to 652, and there are 47 data values in there. The next one goes from 652 up to, and it's kind of weird the way it does this, is that actually R doesn't like to write 4-digit numbers. So it puts it into what we call scientific notation. So 1.28 E plus 3 actually means 1.28 times 10 to the third in scientific notation. You can write 1.28 times 10 to the third. You have that ability. Computers and calculators don't. So they usually use an E notation. I've seen capital E's, I've seen small e's. So 1.28 E 3 just means 1.28 times 10 to the third, and I do expect you to write it in that scientific notation the correct way. You can also say 1.28 times 10 to the third is 1,280, and you're more than welcome to reconvert this back over. And then you can see that there's 3 in this class, there's 0 here, there's 1 here, and there's 2 in the last class. And you can see our last class starts at 3180 and goes up to, or 3,180 and goes up to 3,810, which does in fact contain the last maximum. All right, and that's all there is to creating a frequency distribution. You can now actually copy this by just highlighting like I just did, where you just drag your mouse and your cursor and you highlight all of it, and you can copy it and paste it into a Word document. At that point, it won't be very pretty looking, so you can actually make it into a table in Word to make it a little bit prettier looking. You can, by the way, at this point, create a histogram of this, if that's what you want to do. So you can do a histogram of this information. The other thing that might also be interesting is to kind of find out your cumulative frequency. So there are 47 people that had survival times less than 652. There are 11 people in this grouping, but there are 11 plus the 47, or 58 people that had a grouping of 1,000 that had survival times of less than 1,280. So we can actually do a cumulative frequencies. You can do this yourself, but you might as well let R do it for you. And it just means creating a new variable. And again, you can call these anything you want. I'm going to call it cumulative cancer.cum frequency. And there is actually a notation in R to say I want to do a cum sum of that cancer.frequency variable that I just created. Again, you can look at this, but I do want to point out that what I'd like to do is add in the fact that there are less than 20 survival time. There are nobody. So I want to actually include that 0 that's in this grouping beforehand. And so I'm going to create another new variable called cumfreq0. And that one is going to include where I'm going to combine, and that's what the C represents, is combine these, the number 0, with this this cancer, dot cum frequency that I just created. And then I can look at the cumfreq0 and see what this looks like. So again, there's 0 here. There's 47 in this class. There's now 58 here, 61, 61, 62, and there's up to 64, because there actually are, I was wrong about 63, there's 64 data values. Okay. If you'd like to graph this, there is a graph for cumulative frequencies. It's called an ogive. To create this, you want to plot, and this is actually a plot that we do a lot. You want to plot your breaks and your cum frequency that we just created of 0, the cumfreq0, because you do want to include that 0 in there. And just as before, you want to type in your own title, ogive, let's say cancer type, cancer survival times, let's call it that. And you might want to put in your own X label, which is time in days, and your Y label. In this case, these are cumulative frequencies. All right, and then just hit enter, and it will plot it up. Now, again, I'm going to go ahead and make this window smaller so that you can actually see it. I just realized I spelled ogive wrong. I'd like it to be spelled correctly, so I'm going to go back into R, I'm going to bring back the previous line. I'm going to go up. Whoops. I'm going to arrow over. And I'm going to spell ogive correctly. All right. So notice nothing seemed to happen, and that's because the graph is still behind me. And now you can see this is what it looks like. I would like to connect the dots just because in an ogive, usually the dots are connected to help us to analyze things later. Don't close this window. You need to have this window open when you go to put the lines in. Go back to the R console just by typing in, picking that R console window. And you're just going to say you now want to do lines. And lines of your breaks and your cum frequency, 0. And so now if you go back into your thing, you can see now that it's created some lines with your plot. Again, you can now copy this and paste this into a Word document. And that's all there is to doing this and creating this information.